Welcome back. The objectives of this video is to explore inverse trigonometric functions. We're going to rewind and take a look at the horizontal line test. We'll define arcsine and evaluate it. We'll graph the arcsine function. We'll evaluate other inverse trigonometric functions, and then we'll use our calculator to evaluate inverse trig functions. So let's take a look at what it means to have an inverse function. For a function to have an inverse, it must be one-to-one and it must pass the horizontal line test. So take a look below at the graph of y equals the sine of x. Let's take a look at this just in a particular interval, the blue portion, between negative pi over 2 and pi over 2. If you have the unit circle, this would be the whole right side of the unit circle, quadrants 1 and 4. So when we look at the blue portion of our sine curve here, we see that the sine curve is increasing over this entire domain from negative pi over 2 to pi over 2. And the sine curve also takes on its full range of values. It takes every value between negative 1 and positive 1. And again, it passes the horizontal line test, so this is 1-to-1. So in the restricted domain, sine is going to have an inverse function. And we denote that inverse function by saying y equals the arcsine of x, or y equals sine negative 1 of x. So that negative 1 isn't reciprocal. It's saying it's the arcsine. Okay? So now remember, for an inverse function, we flip the x and the y. And I think I have that written in the notes below as well. So when we say something like y equals the arcsine of 1, what we're putting in here now is our ratio, and we're going to output the angle. Usually we put the angle in, and we get a ratio, but now we put the ratio in and we get our angle out. And of course the arcsine of 1, okay, is pi over 2. So our result here is pi over 2 radians. So we flipped our inputs and outputs here. So here's that note. When evaluating the inverse sine of a function, remember the phrase, the arcsine of x is the angle whose sine is x. So we're going to output our answer as an angle. Remember, for an inverse function, we're switching our inputs and outputs. When calculating the sine of x, we're inputting an angle to output a ratio. Now we're doing the opposite. So let's evaluate the following. But we're going to evaluate them on the interval of negative pi over 2 to pi over 2. So we're going to really be working in quadrants 1 and 4 here, right? From negative pi over 2 to pi over 2. So we can discount this entire side of the unit circle. We're not using that right now. So the arcsine of negative 1/2, that would be the angle whose sine is negative 1/2. So if I go on my unit circle and I look for a y of negative 1/2, I find that in the fourth quadrant, and the arcsine of negative 1/2 is the angle 11 pi over 6. B says find the arcsine of the square root of 3 over 2. Now remember, there's multiple places where the sine is square root of 3 over 2, but we're only looking in the first and fourth quadrants here. So I found that, and that of course is at pi over 3. We're answering in radians here. C, the arcsine of 1, so the angle whose sine is 1. Not negative 1, but 1, so we're up here. It's a quadrantal. It's 90 degrees, or pi over 2. And D, the arcsine of 2. Well, we're looking for somewhere where the sine is 2, and we should know that our range for the sine function is only between 1 and negative 1. So this is no solution. Our range is always between negative 1 and 1 for sine. In objective 4, we're going to graph the arcsine function. So y equals sine of x is x equals sine of y. So arcsine x is the same as the graph of x equals the sine of y. When our x's are going to range from negative 1 to 1, normally that's our y's, but now it's our x's. And our y's are going to go from negative pi over 2 to pi over 2, right? We're graphing only the fourth quadrant and the first quadrants. So we're graphing that right-hand side of the unit circle. When x is negative 1 on our unit circle, y is negative pi over 2. So I've set up my graph. My x's, I've gone from negative 1 to 1. My y's, I've gone from negative pi over 2 to pi over 2, but I did it in pi over 6's. So my first point, negative 1, is negative pi over 2. And I'm going to skip the negative square root of 2 over 2, and I'm going to go right to negative 1/2, and I get negative pi over 6. And I pass through the origin at 0, 0, and at positive 1/2, I get pi over 6, and at 1, I have another pi over 2, or 3 pi over 6. Now, if I did want to get a little bit creative here and look for negative pi over 4 and negative square root of 2 over 2, that's going to be about 0.7. And that point is going to be right about here. So the reflection of that point, again, is going to be right about in here. So my inverse function is going to look something like, not my best graph, but it's going to look something like that. So looking at our inverse functions, this is going to be an important table. Keep this handy. The domain for the arcsine, our domain is going to be between negative 1 and 1, and our range is from negative pi over 2 to pi over 2. So the right side of the unit circle. Now for cosine, that's going to be a little bit different. Okay, our domain for cosine is going to be the same. That's between negative 1 and 1, just like the sine is. But our range now is going to be from 0 to pi. So now those are going to use the positives on our unit circle, or quadrants 1 and 2. And then the tangent, the domain actually is all real numbers. Lots of options for the domain for tangent. Our range, however, again, we're back to the same thing as a sine. We're in quadrants 1 and 4 here. So we're going to evaluate the following. And remember to pay attention to the ranges listed above. Okay, it tells you where to look on the unit circle. So the arcsine, cosine of the square root of 2 over 2. So I'm looking in quadrants 1 and 2, and x's are square root of 2 over 2, and that is going to occur only at pi over 4. The arc cosine of negative 1, again, in quadrants 1 and 2. Where is our x value negative 1? It's over at pi. Arctangent of 0, where is our tangent 0? Our tangent is 0. It's y over x is 0, right here at 0. Okay, we can't put 2 pi here. Okay, we can only put 0 because remember our range is from negative pi over 2 to pi over 2. And then the arctangent is negative 1. And again, we're working On the right-hand side, we're working from negative pi over 2 to pi over 2. So that answer, 7 pi over 4, right there on our unit circle. We can also use our calculator to get approximate values of the following. Now make sure your calculator is in radian mode. Flip over to our calculator here, and we'll do the arctangent of negative 8.45. So we'll use those sine -1, cosine -1, tangent -1 buttons on our calculator. The arctangent of negative 8.45 gives us negative 1.453. If we want to find the arcsine of 0.2447, again, go to our calculator, second sine, the arcsine of 0.2447, and enter. And I am in radian mode, so I'm getting that right. That's 0.2472. The next one, the arc cosine of 2. Second cosine 2. Enter. And I get an error for that. Well, that makes sense. It's got to be between 1 and -1 there. So that makes sense. So we'll quit out of that one. And we'll go to our last one, the arc cosine of negative 0.349. Now we should get something. Negative 0.349. And we get 1.973 radians for that. So remember, those are all radians. We were in radian mode. There's an introduction to the arcsine, tangent, and cotangent functions, and you'll get some more practice with this when I see you in class.